And so we're going to say 4 squared plus 6 squared has something to do with 8 squared. We don't know if it's equal, we don't know if it's bigger, we don't know if it's smaller yet. Alright, we just know it has something to do with it. Alright, so 4 squared is going to be 16, plus 6 squared is 36, 64. 16 plus 36 is going to be 52. 52 is smaller than 64. Now, this sign right here is meaningless unless I know which side is my hypotenuse. Alright, because if our hypotenuse is big, it's obtuse. If our hypotenuse is small, it's acute. If it's equal to, then it's going to be a right triangle. So you have to make sure that you keep track of which side is your hypotenuse side. So 64 is bigger. So bigger means, anyone shout it out? Obtuse. So it is obtuse. Q. Alright, you probably have to take out your calculator. I mean, you can. There's other ways. Like I can see which one's bigger. But who can tell me which one of those is bigger? 2 square root of 15, 3 square root of 6, or square root of 6? 2 square root of 15 is the biggest out of all of them. And realistically, that's all you'd need a calculator for on this one, is just to recognize which one's the biggest. So once again, we're going to do one side squared plus the other side squared equals 2 times the square root of 15 squared. Now, squaring these can be a little difficult at times. So if you need to write more, I don't have room here to show it again. But it's basically saying 3 squared times square root of 6 squared. So you're basically distributing the square sign. So 3 squared is going to be 9. Square root of 6 squared is 6. Plus square root of 6 squared, which is 6. That's going to equal, well, 2 squared is 4. Square root of 15 squared is 15. So I do them individually. I do my 2 squared, and I do my square root of 15 squared, and just put them next to each other. All right, I don't know, maybe because I already knew the answer, I shouldn't have put equal signs. I should have put, I don't know what it is. For those that know the answer, probably realize why I put an equal to sign, but for those that don't know the answer, the surprises are bountiful from here on out. All right, 9 times 6 is 54, plus 6 has something to do with 4 times 15, which is 60. Well, it's weird I was using that equal to sign because 54 plus 6 is 60. 60 equals 60. So what kind of triangle is this? Right. Right and correct. Right triangle. I think this is the easiest, the equal equals a right triangle. The only thing people are going to mess up on is on these, they're going to forget which side is their hypotenuse, and they're just going to see a less than sign and say it's acute. Okay, don't fall into that trap. Know which side is your hypotenuse. Hypotenuse big, obtuse. Hypotenuse small, acute, equal to, it's all right. All right, today we're going to talk about some, first, I know we had one question on the homework. We were here. It was the very last one. Let's see if I get to it. So the very last one said the sides of a triangle have x, x plus 4, and the longest side was 20. That means 20 is my hypotenuse. So you needed to set this up as one side squared, x squared, plus x plus 4 squared equals 20 squared. Which if we continue to do our math, that's just still x squared plus, just a quick reminder that this is really x plus 4 times x plus 4. So if I FOIL or distribute however you want to, it's x times x gives me x squared plus x times 4 is 4x plus 4 more x's is 8x. Plus 4 times 4 gives me 16. That's going to equal 400.
Wait, does it equal?
Oh, we don't know, do we? No. So what I do on these is I set it, because technically, in order to use the zero product property or to use the quadratic formula, we always have to set it equal to. And then we should know at the end, because I'm looking for where it's acute, then we put a less than sign at the very end. All right? Greater than, I'm sorry, I can't remember if I'm looking for acute or. Yeah, so we put well, it depends on which way you're looking at it. We want our hypotenuse to be smaller, right? Okay, so as we go down solving this, we're going to notice that our x squareds do not cancel out. We're going to have 2x squared plus 8x. I would subtract 400 from both sides. So that's going to be negative 384 equals 0. Now the first thing I'd probably want to do is I'm going to realize I need to factor this, right? I need to factor this, and the first thing I probably want to do is put it in its simplest form before I factor. And that's going to be, well, I can bring a 2 out of each one of these. So I'm going to rewrite this as 2 times x squared plus 8 divided by 2 is 4x minus 162. Oh, yeah. Did I make a mistake already?
No, I was wondering, why couldn't you just divide 0 by 2? Like, instead of factoring, why couldn't you just divide everything?
Oh, you absolutely could. You get the same exact answer. So what she's saying is divide both sides by 2, and then your 2 completely cancels out. It's going to be the exact same answer either way. Yeah.
Is it 162 or 192?
It is 192.
One,
192.
I got 196. Is that wrong?
Yes.
Oops. Oh, I just got all of them wrong.
Right, we have 192, right? When we divided 2 out.
I just put
Because
392.
190 times 2.
Yeah, that's what I got. I didn't get
Okay.
the 34.
So, quick reminder, if you want to factor this, I'm not going to go through everything in step. I always do the A times B. And my C column, my A times, I'm sorry, I completely messing up after I messed up that number. It should be an air conditioning column and a Beyonce column. Well, A times C would be 1 times negative 192, so we have negative 192. Our B column would be 4. So I'm looking for 2 numbers that multiply together to give me 192, and the difference between them is 4. And who has those numbers? I think it was 16 and 12, yeah. 16 and 12. So you got to work through this and figure out that 16 times 12 equals 192. One of them needs to be negative. Which one needs to be negative in order, when I add them up, they give me a positive 4? Yeah, 12. So 12 needs to be negative. So I'm going to leave the 2 in there. A lot of you might have divided both sides by 2. I'm just going to leave it in there. But basically, we're going to have 2, let me rewrite everything really quick, x squared plus 4x minus 192 equals 0. I'm going to rewrite this as x squared. I'm going to split apart that 4x into negative 12x plus 16x minus 192 equals 0. Now I'm going to treat this as 2 different binomials. So I'm going to leave that 2 outside. And my first binomial I'm going to pull an x out of, so it's x times x minus 12. And the other one I can pull out a 16 to give me x minus 12 as well, because 192 divided by 16 gives me 12 equals 0. So then we have 2 times x plus 16, because we smoosh these 2 together, times x minus 12 equals 0. So either our x is going to be positive 12, because 12 minus 12 is 0, that will give me 0 using the 0 product property, or my x is going to equal negative 16. Can I have a negative 16 length?
No.
No. So, not in geometry. So either x equals negative 16, which does not work, or x equals 12. All right, now we got to relook at the question. The question says, specify the values for x in which the triangle is acute, right? So we want our hypotenuse to be small, correct? So that means this is my hypotenuse side. Yeah. To make it acute, our hypotenuse is supposed to be small because it shrinks it, right? In order for our hypotenuse to be small, I'd have a greater than sign here, right? So that means rather than x equals 12, to get my full answer, we're going to say x is greater than 12, and that's our final answer. Okay, so it just took a lot of factoring in there. I think that's what threw people off. So it's either factoring, or if you want to, you can use the quadratic formula as well, if you're one of those people that like using it. I am not one of those people, because that generally involves having a calculator or something, where you can usually factor or complete the square all on a sheet of paper. Okay, any other questions really quick? Okay, good. So I'd like to give you some time to work. Let's go ahead and do today's lesson, which is just special triangles. What makes them special is the relationship between the three sides of the triangle. And more specifically, we're going to talk about two types of triangles. They're called 45, 45, 90. And the other one is 30, 60, 90. And every rule I teach you today works for any triangle that has the measures of 45, 45, 90, or 30, 60, and 90. Every triangle. So that means on a test, if you see something that says 45 degrees and you see a 90-degree angle, it's going to tell you to use this first one, which is 45, 45, 90-degree triangle. Anytime you have a 45, 45, 90 triangle, your hypotenuse is going to be square root of 2 times bigger than the legs. And we'll write it down there so we don't have to worry about it. So it's square root of 2 times bigger than the legs. Now if I have a 45, 45 degree, 45, 45, 90 triangle, what type of triangle is it? Isosceles. It must be because it has two of the exact same angles. Any triangle that has the exact same angles is going to be isosceles. That means the legs are the exact same.
Yeah, I'm assuming it's the right triangle too.
If it's 45, 45, it would have to be if you had two 45-degree angles.
Never mind,
If you have just one 45-degree angle, it doesn't automatically make it a right triangle.
I know, I meant like, it was a stupid question because
Oh, okay.
triangles have to equal 180.
Gotcha.
When you say bigger than the legs, do you mean bigger than one of the legs or bigger than both of them added together?
I'll show you. I'll show you down here. So, as we know, both of our legs need to be the exact same size. And our hypotenuse is obviously going to be across from our 90-degree angle. So our hypotenuse is right here. Oh, I didn't even finish that. So this is going to be my leg, and this is going to be my other leg, but they're both the exact same size. So what we're going to do is we're going to note what everything is on the other thing. So I am going to label this the same every single time. Anytime I see a 45, 45-degree angle, I'm going to immediately, whether there's numbers by it or not, I'm going to label it as S, S, and S times square root of 2. I'm going to write that down every single time I see a 45-degree triangle because it makes solving them a lot easier and you make a lot less stupid mistakes. Okay, so we have S, S, S squared of 2 because it is isosceles, so that means the two sides are the exact same. And the reason why I'm going to label that every single time is let's look at that first example. It says find the lengths of the missing sides. So if I do what I just told you to do, I would label this side S, S, S square root of 2. Now I labeled this side S, so this whole length is S, so S must equal 5. S must equal 5. That's important because that means AB also equals 5. AB equals S, which equals 5. So we have AB done. Well, AC, length AC, that's going to equal S square root of 2. So let's just do a little math. S square root of 2, if I plug that 5 in, is going to equal 5 square root of 2. So AC is actually going to equal 5 square root of 2. And if you don't feel like writing S square root of 2 every time, that's okay. I'm not going to take points off for it. But I found that when students struggle with these, as soon as I tell them to write the letters down, they write them all down and they start solving like, oh, never mind, I got it now. All right? So if you get stuck, make sure you know all of these ways to write it down. So I'm going to do the same thing for this one. I see it's 45. That means this has to be 45. My two legs are going to be S, and my hypotenuse is going to be S square root of 2. And as soon as I write that down, I know S square root of 2 has to equal 4, because these both stand for the same thing. So I'm going to go over here, I'm going to write S square root of 4, not X square root of 4, X square root of 2 has to equal 4. And now all I have to do is solve for S. And then to solve for S, I'm going to divide both sides by square root of 2. My square root of 2 divided by square root of 2, that cancels out. And I'm just left with S equals 4 square root of 2. And yes, S equals that, but I'm not done solving for S. Why can I not quit right now?
You can't have a square root in the denominator.
Absolutely, I can't have a, in fact, need to get rid of that square root in that denominator. So we're going to multiply the top and bottom by square root of 2. Which is going to equal, let me go ahead and do it below so I have more room. We're going to have 4 square root of 2 over 2, which actually equals 2 square root of 2. So our S equals 2 square root of 2. Well, AB, length AB, actually equals S. Well, S equals 2 square root of 2, so we found AB. And in fact, BC is the exact same thing. BC will also equal S, which equals 2 square root of 2. So those are all pretty easy as long as you label your S's and your S square root of 2. I'm going to skip the next two examples because they're pretty much the exact same. Just to give you some more time to be able to work. I want to jump right into our 30, 60, 90 triangle. Now in a 30, 60, 90-degree triangle, our hypotenuse is twice as large as the shorter side. So I put it is 2 times as long as the shorter leg. I'm going to skip a note real quick because it's going to say in the note. If I had this triangle right here, I have no numbers here. I just have the 30 and the 60. How do I know which one's the shorter leg? One's shorter, one's longer, and I can't judge it based upon how it looks. I can't say, well, Mr. Pavian drew that one a bit longer, so I'm going to say it's that one. What's a more mathematical way to figure out which one's longer and which one's shorter? The one across from the shortest angle. So if I have 30 degrees, 30 degrees is my smallest angle, so it goes across to the shortest side. Which means 60 degrees is my second biggest, which is going to be my longest leg, right? My longest side is always my hypotenuse, but this is going to be my longest leg. So my longer leg, and this is going to be my hypotenuse. All right, let's go back up to the notes. And the longer leg is going to be square root of 3 times as long. as the shorter side. So the shorter leg is always opposite the smallest angle. That's important to remember. And Hannah already told us that, but now we have it down in print. Okay, so now write this down. I'm going to go ahead and call the shortest side S, which makes the longer side S square root of 3, and it makes my hypotenuse 2 times S. So once again, if you want to really succeed at these, the first thing you're going to do is you're going to note you have a 60, 30, 90, and then you're going to write these variables higher. You don't have to use S. If Tori wants to use V, she can use V, and she can have two V's, and then a V, and then a V square root of 3. Jack wants to use a J, you can use a J. If you like using X's, just use X's. You don't have to use an S. I'm just telling you, through history, students that write this down are more often the ones that get it correct, or at least practice doing it, are the ones that get it correct, and they don't get stuck as easily. So we're going to do that. We're going to say, well, I see I have a 60 and a 90, which means this has to be a 30. Which means the side opposite my 30 is going to be my S. My hypotenuse is 2S, right? Because if we look back here, we got 2S. And the other side is going to be S square root of 3. Now I'm just going to pick the side that's already has a number for it. That's this side. So 2S, so in other words, 2S equals 14 because they came from the same side. Let me change the color on that. Because they came from the same side. Well, if 2S equals 14, I divide both sides by 2. I'm going to have S equals 7. That's important because MN happens to equal S, which happens to equal 7, and we are almost done. Because side LM equals S square root of 3. So S square root of 3, if I plug in my 7 for that S, is going to equal 7 square root of 3. So LM is going to equal 7 square root of 3, and we are done. So every one of these boils down to the exact same process. Decide if it's 60-30, 45-45. Write these variables down. Figure out which side's already given to you and set that side equal to that number and solve for the variable. All right, in this case it's S. All right, if I'm doing this one, once again I have a 60 and 90, which means my missing one is 30 degrees. My shorter side is the one across from 30, so this one is S. My hypotenuse is going to be 2 S's. And finally, that longer leg has to equal S times square root of 3. Well, we already know what S equals. S equals 2 square root of 5. And that's given to us. As long as you wrote it down, we know that this is true. All right, so that means that let's do the long leg, which is S times square root of 3. That's going to equal me plugging that S in. So that's going to be 2 times square root of 5 times square root of 3. Now we got to simplify that. We can simplify it by going 2 times square root of 5 times 3, which just equals 2 times the square root of 15. Can I simplify square root of 15? Does 4 go into it?
No.
Does 9 go into it? I can't do that. So we know whatever side is S square root of 3, which turns out is LM, equals 2. So LM equals 2 square root of 15. All right, I just got to get this side, NL. Well, NL equals 2 times S. So 2 times S. Recall that S actually equals 2 square root of 5. So 2s equals 2 times 2 square root of 5. Now this is just a chain of multiplications. Alright? So we can actually write this as 2 times 2 times square root of 5. We don't have to put those parentheses, so it could be 2 times 2 times square root of 5, which equals 4 square root of 5. So that's one of my answers. That's my other answer. Kind of ran out of room. I'm just going to kind of write over here. Hopefully you have a little bit more room. You wrote a little smaller than me. But ln equals 4 square root of 5. And you can write into this one because we're not doing this one. This one's supposed to be blank. Actually, if you look at it, it's already example that we did. So that one's just gone. We're not going to do that one at all. I only want to do 2 or 3. Our last one says find the lengths of the missing sides. So once again, I look at my 60 degree. I know I have 30 degrees up here. The side opposite is going to be S. My hypotenuse is going to be 2S. And the long side is going to be S square root of 3. Once again, I'm going to pick that side that already has a number by it. That guy right there. And I'm going to set it equal. I'm going to say, well, S square root of 3 has to equal 8. To solve for S, I need to take and divide by the square root of 3. So I'm going to have S equals 8 divided by the square root of 3. But I cannot have square root of 3 in the denominator. So I need to multiply the top and bottom by square root of 3. And I'm going to see I have S equals 8 times the square root of 3 all over 3. And since S equals 8 square root of 3 over 3, I look at which side equals S, and we know that Mn equals S, so Mn must also equal 8 times the square root of 3 over 3, and we are halfway done. Actually, more than halfway done. Because the only side we're missing is 2 times S. That 2S is missing. So we have 2S. Well, I'm going to plug in what S equals here. So we're just going to have 2 times 8 square root of 3 over 3. So S is going to equal 16 square root of 3 over 3, which means ln is going to equal 16 square root of 3 over 3. And we are done with that one. All right, questions on any of that? Let me go over real quick your thought process. If you have a 45 degree angle, you're going to label your sides S square root of 2. Then you're going to pick the side that has a number by it, and you're going to set whatever variable you had next to it equal to that. So this one was S equals 5, and that will get you the rest of them. All right, sometimes you actually have to solve for your S. In this case, we said S square root of 2 equals 4. Had to actually solve for our S, but once we had our S, we were pretty much done. And the same process works for 30, 60, 90, as long as you remember that it's S, 2S, S square root of 3. So your whole thing that you need to do is you need to memorize what happens when you have these triangles. All right, what you write there and what happens afterwards. That has to be memorized. Okay? That'll be the difference between these being hard problems or easy problems on the test. All right, go ahead and get started on your worksheets.